to get the answers to the worksheet, and let's find f of negative 5. Okay, said it's what? It's 6. Okay, now this is actually find the value of the function. What's f of 2? Look right there. Okay, okay, 1. I can write it. F of 4. Well, this is a closed circle. They just didn't draw it in. So it's negative 3. The limit won't be equal. These are just values of the function. Okay. Then, what's the answer to number 4? Now, this is a limit. Remember, the limits have to be the same from both sides. So you're traveling on the road towards negative 7, and your friends are traveling on the same road. You have to be on the same road. And in the limit, you will meet. But before you get there, you're approaching the same location, which is 2. Does that make sense? You're just approaching that. What are you getting close to? Doesn't matter if it's a hole. We don't care what happens at that point. If I keep closing the door halfway, and I'm only closing it halfway, will I ever get it closed? No. But in the limiting sense, if I could keep closing it halfway an infinite number of times, the door will close. Right? It's the limiting sense. If I get closer and closer and closer, so close, I do it an infinite number of times, I'll get to 2. So what are you approaching? Okay, what about at negative 5? X approaches negative 5. This one's not too bad. It's what? It doesn't. Now, there's other issues there. What about X approaching 2? Now, you're traveling on these roads. Will you get close to each other? If you could do this to infinity, you would meet. And where are you going to meet? 3. That's what you're getting close to. That's all the limit is. What's the y value? Getting near. Okay, what about the limit as x approaches 4? Well, this one I'm going to come down this way, and this one I'm going to come this way, and it doesn't exist. Why? Left doesn't equal the right. So it looks like we got that one. On the exam, you might have to say the left doesn't equal to the right. Okay, how about 0? Now, it does not exist. If it had 0 plus, and I think it does over here, then we'll actually give more information. But right now, the left and right sides aren't the same. So that does not exist. What is the limit 0 from the left? Negative infinity. And 0 from the right, I have to slide it a little bit. You're going up this way, it's positive infinity. Okay, and I really don't know why they did 4 here, where they really should have looked at 11. 11 and 12 should be done first. What is 4 from the right? I'm going to go to x equals 4 from the right, so I'm going to end up at negative 3. I'm in a different county. 4 from the left, though, is coming down this way, and it's at 2. And because these are not equal, that's why this does not exist. The limit from the left. They really should have asked questions 11 and 12 first. Because when you see that they're not the same value, the limit can't exist. It's a one-sided limit. The question is, why does number 11 not exist? It does. Usually, I'm not going to say always, but usually one-sided limits will exist. Yes. Now, these are the horizontal asymptotes. They're both positive infinity. This is going to what? 0. Negative infinity. This is going to. You must check both. There's no guarantee that they are the same. I will bring in some AP questions. One in particular was 2008 was thrown out because very few people got it right, if anybody. But there was also a trick. One of the answers you get was the first answer, but the actual answer was the last one. So what happened was students read through the first answer, said, oh, that's the answer, didn't read all the answers. Read all the answers. Sometimes they try to trick you. There's test-taking skills to the multiple choice. Okay, use the definition of a continuous function to answer these questions. Okay, what is the definition of a continuous function? What's the first thing? The function must exist at that point. Now, on your test, this is a test question, and it's got to be exactly right. You can't say f of x must exist. I'm going to mark it wrong. What else has to be true? Because it's at a particular point. At this value. Okay? What else has to be true? The limit as x approaches c must exist. Because you are going to be given problems. You're going to have to do some algebra. They're not going to be pictures. Where you're going to do the algebra, and you're going to tell me why it's not continuous, or if it is continuous, why it is continuous. Because remember, all polynomials are continuous. All rational functions are continuous, except when the denominator is 0. What's the third one? The limit as x approaches c of f of x must equal f of c. Okay, you can't mess up all these x's and c's. They got to be in the right place. I'll mark it wrong. Okay, Sam? Is that okay? So why is this not continuous at negative 7? F of negative 7 doesn't exist. That's why. I always look for that one first, because that's the easy one. And if it does exist, then I'll have to do some more work. That's it. You don't have to do the other ones. The limit does exist, but the limit's not equal to the function. But all you need to do is have one of these not work, and that's all it takes. So f is not continuous at x equals 2. Does the function exist at 2? Yeah. What's the problem with this one? The limit from the left is not equal to the limit from the right. Oh, I'm looking at the wrong one. That's 4. We'll get to that one. Okay, why is it not continuous here? Oh, does the limit exist? Yes. Does the function exist? Yes. But it's still not continuous because the limit doesn't equal the function. Now, I could do, little Quizlet flashcards on this, but, I've got so much to do. You got to know these. What do you mean? It is at 2. Oh, yeah. You want me to write it with the 2s there? Yeah. No, that's right. Okay, then I did 4 by accident. Yes, check. Okay, what about at 4? What's not equal? The limit does not exist because the limit from the left does not equal the limit from the right. And they might ask you to write out why the limit doesn't exist, and it's enough. You can do it formally, or you can say limit from the left doesn't equal the limit from the right. Doesn't really matter. You can say it in words, or you can say it formally with the limit. Okay? Does this worksheet okay? Did it help clarify some things? Yes, you're on the test. You're going to be doing some problems, like the homework that you're going to ask me questions about, fixing some discontinuities, knowing the definition of continuous, and then you're going to have to, I'm going to give you some functions, and I'm going to say, where is it discontinuous and why? Or if it's not discontinuous, tell me why. And then there's a little bit of a graphing problem, and then there's a page that looks just like the limit worksheet and limit quiz. And then on the back, there's some more stuff with limits. Okay? And you have a practice one I'm going to give to you tomorrow, very similar to the test. So if you can do that, you can do the test. Okay, any questions on this? Is this okay? Now, we are going to finish up with the intermediate value theorem. Oh, did I not bring that up? Okay. It's 2-3, day 3. Whoops. You're right. This is day 3. We did day 2 yesterday. Yes, but it's better on day 3. You're right. We didn't finish day 2, but the handout for day 3 is better because it looks like that. I'm thinking it's blue, maybe yellow. You should have it. It's green. There are about 6 theorems you have to know for the AP exam. This is one of them. Okay, you guys ready? You know, when I do the recordings, they are real time, unfortunately. I think you can fast forward. Yes, it's green. You could use the back of section 2. It doesn't matter. This is just a better picture. Okay, now, you guys, this is the intermediate value theorem. You may call it IVT. You use it all the time. You may not realize it, but let's say you got up in the morning and it's 10 degrees below zero, and when you get home from school, it's 10 degrees above zero. And you might say to your parents, when did it cross zero? When was it zero? We talk about that all the time. If you listen to the weather, they'll say, okay, it's 20 degrees below zero. The question is, will it get above zero? It's the intermediate value theorem. If it starts at negative 10 and goes to positive 10, because temperature is continuous, don't you think it's zero sometime? I don't know when, but it is. But isn't it also 1 degree sometimes? Could it be pi degrees sometimes? Yeah. Okay, that's the intermediate value theorem. All it is. It's saying that on an interval, if it starts at negative 10 and ends at 10 somewhere, it has to hit all numbers between negative 10 and 10. And it's been on the exam. I'll bring in the examples. You just have to recognize it. That's the tough part. If they did it with temperature, it would be obvious. But they did it with numbers last year. Then it's not so obvious. So the formal theorem, and you're never going to have to say this, but the condition is you have to have a continuous function on a closed interval. So there's only like 6 theorems you have to know. This is one of them. What you have to know about this is the fact that it's continuous and it's a closed interval. So if I could take the endpoints, I could take any part of this function. So if we call this A, and we call this B, then this is f of A, and this is f of B. And all it's saying, all this term says, is if the function's f of A and it goes to f of B, it'll pick up all values in between there. That's all it says. Kind of wordy the way they say it. Don't worry about it. Just know that that's what it's saying. So on your graphing calculator, and I'm sorry, my smart key's not working, but I don't know if you've ever had this happen, and you're looking for a zero. It happens to me because I'm not always slow on putting these in. Well, remember you have to put in an interval, and they say we want to check from here, and then you would check from over here. Because if my function's positive here and then negative here, it has to be what? Zero. So if I don't even know what interval I want, if I can just find some values where the function's positive and then the function's negative, then it has to be zero in between there. It doesn't tell me where. But have you ever done this where you entered the left bound and you entered the right bound, but you put it here and you can see the function's not crossing zero? Have you ever made that mistake? Yeah. And what does it give you? It gives you an error. And it says no sign change. So what it's doing is the intermediate value theorem. It's saying the signs have to change from positive to negative. It happens to me all the time. If you have a discontinuity, you've got to be a problem. Now, that's not to say not all these values will happen, but there's no guarantee. This is a guarantee that if this is negative 5 and this is positive 20, I will pick up all values between negative 5 and 20. If it's discontinuous, I could have a discontinuity right there. It's still going to pick up all values from negative 5 to 20. But that's not a guarantee. This is a guarantee. I like guarantees. That's what the bottom half says. So let's look at just quick examples. I'm not even going to do that one. I just skipped that one. I just went right down here. Because this is what it's going to look like on the test. Use the intermediate value theorem to show that there's at least one root, in other words, 0. I don't know if you've heard the word root, if the teachers use that or not, on this interval. Well, when they give you this to you in the exam, it's going to be as easy as this. You are going to evaluate the function at the endpoint, and they set it up so it's going to work. So it's going to be f of 0, which is, what's f of 0? 0 minus 0 plus 1. It's 1, right? So it's positive, right? And what's f of 1? Well, let's see. It's 1 minus 3 plus 1. What's that going to be? Negative 1. So it's negative. Well, it was positive. Then it becomes negative, so it had to be 0. Didn't it have to be a half also? Yeah. So if they say, show that a function has a value of 1/2 or negative 1/2, whatever, on this interval, you're always going to substitute the endpoints in. There's not going to be any tricks. You have to play with it to get it to work. It's always going to work. And you're going to say, oh, it's a half because that's a continuous function. I don't even know if it has to be a closed interval, to tell you the truth. But probably does. This probably should have been, probably my typing, probably should have been close. And you should say by that intermediate value theorem. So now, I'd say by the intermediate value theorem, and f of x is continuous. You could even do it in phrases. Therefore, oh, that's a symbol for therefore. 3 little dots. Did you guys know that? Okay. Therefore, f of x has to equal 1/2 or whatever value. And we'll do the problem. I made it up. Picks up all values between what? 1 and negative 1. Yes. They'll say, show that it's equal to a half. And then you would evaluate it f of 0 and f of 1 and say by the intermediate value theorem. You don't even have to state the theorem. You just say using that. The next problem has an issue because it's 2 functions. So instead, what I'm going to do is subtract these. I don't like finding intersection points. If you graph y equals x cubed and y equals 3 to the x, and I'm sorry my smart key's not working, otherwise I would do it, you'll find that the curve looks like this. There are 2 intersection points, and so x cubed might look like this. You know, they're right on top of each other. Even if you zoom in, it's really tough to see where those 2 graphs are equal. So it's easier to just subtract them. Because if I subtract them and they're intersecting, what's going to be the answer here? X cubed minus 3 to the x is, if they're equal, 0. So it's easier to look for zeros. I know some of the other teachers always look for intersections. I don't do that because if I just look for zeros, I don't care how tall my window is. I don't even have to worry about it. I just have to worry about the x's. That's it. If I try to get this intersection, I got to worry about what the y values are. That's a lot of work. So I'm going to subtract these and look for the zeros. So here's my function. F of x is the difference in those 2. And let's just evaluate the endpoints of the interval. That's all you're going to do in the exam. You're never going to try and find any other point. It'll always be the endpoints. So what's f of 0? The cosine of 0 minus 0. Now, do you guys know what the cosine of 0 is? 1. Good. Now, this next one's a little trickier. It's going to require me to think. Let's pretend this is non-calculator. So I want to do f of 1. So that's the cosine of 1 minus 1. Now, these are radians. You guys remember about how big 1 radian is? 60 degrees. 67 something. Yeah, 60 is close enough. Now, the cosine is always trapped. You're thinking this in your head. And when you're on the exam and you're wondering what to do, you're going to imagine me sitting next to you saying, now think about it. Cosine is between what? 1 and negative 1. I know it's not 1. right? I know for a fact it's not 1. So that means it's smaller than 1. So what's true here? Is that positive or negative? It's negative because this is less than 1 here. So this is going to be less than 0. This was greater than 0. Someplace it's got to be 0. Actually, it's 0.739, I think. Why do I know that? Because that's due to chaos theory. We could do chaos theory after the exam. That'd be another option. Yes. I don't believe we're testing on that, no. But it will be on the exam. And I get more and more data, which is nice. And it will always be somewhere on the exam. It might be in the multiple choice, and it might be in the free response. But I can tell you this, I can guarantee this, that every topic we teach, unless I say this is not on the exam, will be asked somewhere. So the rule of thumb is if you see it in the multiple choice, you know it's not going to be in free response. Might not be. I shouldn't say it won't be. But I guarantee you will see it somewhere. So they did this on the free response, I believe, last year, so it probably wasn't in the multiple choice. Now, the big theorems, the fundamental theorem of calculus, you will see in both places. And you'll see that multiple times, even on the free response. We haven't gotten there yet. Okay. How do I know that? Because the chief reader, I asked him about that because we do polars in BC, and I said there were no polars in the BC exam. They weren't in the free response, but they were in the multiple choice. He said to me, every single topic that's listed is somewhere in that exam, sometimes more than once. I think this will only appear once. Okay, so now we have time to do questions on homework, because some people had a lot of questions on homework. Oh, it's positive and then it's negative, so it's 0 someplace. I don't know where. By the intermediate value theorem. You would just say, let me go down here. So you would say, if this question is show that it's 0 someplace, these have to be intersected on that interval because it must be 0. So f of x equals 0 on the interval 0 to 1 by the intermediate value theorem. The calculation's good enough. Positive. You might have to say the function changes as a positive to negative. Usually not that picky. Sometimes they can be, though. And by the way, it changes with the chief reader. Last year's chief reader, is this my book? Yep, that's mine. The chief reader has a direct influence on the exam. So previous years, if you made a copy error, hey guys, if you made a copy error, and as long as it was clear it was a copy error, you got full points. Not last year. If you made a copy error, you lost a point. But don't miscopy numbers. I liked it the way it was because I thought that was more fair. Because when you take that test, you're very stressed. Okay, section 2.3, there may be other questions. Now remember, you're supposed to bring your books. Yes, Sam. Which ones do you have questions on? We did 25 and 27, but you may have specific questions. This is section 2.3. We can look at any of them. You know, we didn't graph. Did we graph E? Yeah, we graphed E to the 1 over X. Oh, I know. I'm just trying to learn your name. Casey? Okay. Yes? Oh, those are great problems. I'm going to hopefully have a worksheet on that, too. Should we can, I don't care. We can start with 47. Now, I usually, if I don't, remind me to write that. I won't put a page number down because I don't have those memorized. But I do have the sections. 47 says f of x is equal to this. And here's a problem. Graphing that could be a problem. We could make a little sketch. And it says, find a value for a such that this is going to be continuous at 3. So if I graph this, do you guys know what x squared minus 1 looks like? It's a what? And it goes through -1. So it goes here until we get to 1, 2, 3, right? I don't know exactly sure where it's going to be. Then we're going to stop. There's a hole there right now because it says x is less than 3. What's this graph going to be? A is a number. It's just going to be a what? A line. I want them to connect. And you remember that the limit as x approaches 3 from both sides of f of x has to equal f of 3. So I have an equation I can solve. What is the limit as x approaches 3? Now, why don't I have to check both sides of this? It's a polynomial, right? Nice little parabola. Okay, guys? What am I going to do next? That has to equal f of 3. What's f of 3? It's 2a times what? What is x, though? 3. See how I get an equation? It just tells me what to do. Find that limit. What is that limit? Brian? What is this limit? 9 minus 1 is 8 equals 2a times 3. I guess I could have multiplied that out. 6a, so what's a equal to? 8, 6. If it's free response, don't reduce. If it's multiple choice, you'd have to reduce it because you have to match it. But it's free response, we'll just leave it. Yeah, that's all it's asking. Now it's continuous. Might be a sharp corner. I don't know. Didn't say anything about smooth. We will add that in later. But smooth. It might look like this. There's a sharp corner here. That's going to matter later on. Not for continuity. I don't even want to use the word. Okay, another one. $33. This was a weird one. Theorem 7 is the one which we didn't finish, but which functions are continuous? Yeah, we filled out one day, but we didn't fill it out yesterday. But what's true? The root functions are continuous, right? And x over x plus, actually that's a 1, that's also continuous because it is a rational function. So that's going to be continuous everywhere except, okay, x can't be negative 1. That's the obvious one. There's another thing, though. What's true about what's under the root? X over x plus 1 can't be, has to be what? Has to be greater than or equal to 0. I don't know if you know how to solve that. You should, but I don't know if you do. Here's the trick to solving any equation. What does solve mean? I'm going to make this really easy. I'm not going to use inequalities hardly at all. Jonathan? Right. Okay. What's it mean to solve? If I solve this equation, x plus 3 equals 5, and I tell you x equals 1, if I solve that correctly, why not? Why is that not correct? Well, I say it's 1. How do you know? How do you know if it's right or wrong? Put it back in, and it has to make a what? 1 plus 3 is equal to 5. Has to make a what? True statement. That's not true. That's what solve means. I don't care how you solve. The process of subtracting 3 from both sides is a process. It's a procedure. What does this word mean? It means to find them. All the numbers that make the sentence true. I'm pretty sure they taught you how to do this last year. But you might not remember. Okay. Is it okay to do this by inspection? When I first started teaching, I said, no, you can't do that. You have to show me subtracting 3 from both sides. I've totally changed my mind on that. Because when you look at that and you can say x is 2, then you know what it means to solve. So we're going to solve this inequality right here. I want to find numbers that make that true. Could I do guess and check? Might take me a while. Or I can look at a boundary method. I'm going to look at when the numerator is 0 and when the denominator is 0, because that's the only place this can change from true to false. And by the way, it had this question in the pre-response on the exam in a different format, but it's still there. So these are the only places that this will change from true to false, is that when this is 0 and when x plus 1 is 0, which is negative 1, right? Now, can I put 0 in? Does that make it true? Yes. You can take the square root of 0. What's the square root of 0? 0. And now all I do is test my regions. And I'm sorry, I'm pretty sure you did this. And you just put numbers in. This is easy. The hard way to do it is to say that x is greater than 0 and x plus 1 is greater than 0. You get half the answers. You don't get the whole thing. Because you'd have to also look at when x is negative and when x plus 1 is negative, because that's also a positive number. This is my response to that. I don't want to do it. I can do it. It's going to probably take me 15 minutes, but I could do it. I don't think you guys would do it, but this is easier. I always like easy. So what's the easiest number you can put in that's bigger than 0? How about 100? 100 over 101, is that positive or negative? That means everything over here will make that true. Yeah, you should have. What about, let's do the next easy one, negative 100. So negative 100 over negative 100 plus 1 is negative 99, so that is positive. And sometimes we have problems with that. And then let's try negative 1/2. Now, they don't always alternate in signs, so you got to be careful. They could always be positive if this is not. Negative 1/2 and negative 1/2 plus 1. This is negative, but this is positive, so the result here is negative. So it's continuous on this interval. And I'm not sure what the answer in the back of the book, if they wanted that much work. I just took advantage of this. Okay, so from negative infinity to negative 1, not including it, because you know you can't divide by 0, and then from 1 to infinity. This is not a calculus question, it's a pre-calc question. And yes, there's a lot of pre-calc being tested on this exam. The square root forces whatever's inside there to be positive. And when you make this statement right here, you get a point, even if you can't solve it. They give you points. The solving part is probably the least important one. Did I write it wrong? Oh, I meant 0. Sorry. I do that once wrong. But if you do the inequality piece, you miss this negative piece. So I don't do that. All rational functions, all rational inequalities, absolute value, they can all be done this way. So throw away all that old stuff that was hard. Now, I'm not sure what they asked you. You'd have to look in the back of the book. But basically, they're saying a root function is going to be continuous everywhere except when whatever's in there is negative. And this rational function is continuous everywhere except where the denominator is 0. The question, if you ever got that, would be far more clear than what this is. Go back, though, and look at the 60s and the 70s. They're not clear. Because whatever's inside of here, because there's a domain problem, whatever that is, that has to be 0 or positive. Domains really, I don't know why you guys have a hard time with it, but what's it say? They're just saying, yes, because this is continuous and this is continuous. So they didn't get as detailed as I did. But they may ask you for the domain of that. So would this be right? Oh, yeah, everything I did was right. I just did more. And on the exam, you don't want to do too much. So make sure you just answer the question and move on. Because kids who answered the question and then did more, if it was wrong, we had to take the points back. Okay, more questions. So I made it harder than it was. But that's okay. It was a teachable moment. What about 27? Or let's do 28. Because 28 is harder than 27. Now, I want to be real careful with this. I don't want you to mess this up. And this is the type of question that's on your test. Same, very similar to this. It says, give a formula. I hate the directions in this book. Give a formula for the extended function that is continuous at the indicated point. Basically, they're just saying, fix the problem. The bridge is out at 0, right? We want to fix the problem, so we're going to fix it this way. We're going to write this. This is what they call their extended function. I've never heard of that until this book. But anyway, sine of 4x over x, provided that x is not 0. And when x is 0, I want to fix the problem. You remember what that curve kind of looked like? It was oscillating, and then it came up like this, and there was a hole at 0. Do you remember that? Yeah, it's that one. That's one you have to know. Yeah, approximately. The hole's not that big, but we have to just fix it. And we kind of know where it's going to be approximately. We have to remember this limit. The limit as x goes to 0, because this is 27. So if we were doing 27, you just put 1 in there. Some people are going to say, okay, I know the answer is going to be what? 4. You're right, but you have to show me the work. Remember, you have to convince the reader that you know what you're doing. So we're going to take the limit. Because remember, f of 0 has to equal the limit as x approaches 0 of my function. Now, I have to fix the problem here. This is not 1, because these are not the same. So remember what we did? This is good review. We put a what here? A 4, right? Well, Ryan, what do I have to do next? Yes, you need to be focused. If I put a 4 here, what do I have to do next? Put a 4 in the numerator. Some of you want to pull out this 4. You can't do that. So if you don't show me the work, I assume the worst. I assume that you pull it out. And I see you guys do it all the time. That's why I know you don't understand that. On the exam, you'll probably be required to show this as well. So I'm going to pull this 4 out. See, that's a different 4. That's why I put the pen down. And so this is equal to 4 times this limit. And we know what this limit is. As long as these match, we're okay. What's that limit? If x goes to 0, 4x also goes to 0. If I want to be particular about it, this is 1. So I'll fix the problem and put in 4. I can put any number I want in there, but I want this hole to be fixed. Okay, so I can put that number if I want, but I haven't made it continuous. You want to make it continuous. So the value you pick has to equal that limit. Casey. Because it's not continuous. They're trying to get you to see when it's continuous, when it's not. You have to do all 3 of those things. So, I mean, that's what you're supposed to do on a problem like, not 19. No, 25. What time is it? Oh, guess it's time. Don't forget, I'm here in 1410. You have day 7 and 8 out of 2-3. So finish up 2-3. Much better to be in front. I want to I could either collect it or I could give you a homework quiz.